to the third part of the NBT preparation tutorial. In the last two parts, we covered questions 1 to 5 of the exemplar questions. Now we'll be trying to finish off the rest of the questions. Question 6 says sine 43 degrees cos 23 degrees minus cos 43 sine 23 is equal to, right? If we are looking at this expression, we can see that because there's multiplication of sine and cos and sine, we can conclude that this resembles a sine compound identity, right? So which are the compound angles of sine? So we have sine A plus B, which is the same as sine A cos B plus cos A sine B. Right? So we also have sine A minus B, which is the same as sine A cos B minus cos A sine B. So because there is this intermingling of sine and cos, we can see that, this is actually the sine compound identity. So in other words, given that we have sine 43 cos 43 minus cos 43, don't forget the degrees, sine 23, we can conclude that our A is 43. This is 23, by the way. Let me erase this. This is 23. And we can also conclude that our B is actually 23. In other words, we can rewrite this and say sine A minus B, because this minus is this minus, as we can see from the equation, from this identity. So sine A minus B, which implies that sine 43 minus 23. In other words, we're going to have sine 20, which is D. Right, question 7 says the angle of elevation of the top of cell phone tower B from the top of cell phone tower A is 30 degrees. The angle of depression of the foot of cell phone tower B from top of cell phone tower A is 60 degrees. The height of cell phone tower B is 100. Let me try to annotate this. 100 meters. So this is what they're talking about. The foot of cell phone tower A and the foot of cell phone tower B are in the same horizontal plane. The height of cell phone tower A is. To solve this question, we are going to do a little bit of extrapolation. In other words, we are allowed to do this, and we know that this will be 90 degrees. And because of this, now this becomes a rectangle where we have this being equal and this being equal. Because they are in the same horizontal plane, it means now this is parallel to this one. Of course, it's a rectangle, and this is also parallel to that side, which means if we know that these two are parallel, we can say that this is 60 degrees because it's alternating this one. And if this is 60, it's just 90 minus 60 to get 80 here. We are trying to find this length, and this length is actually equal to this length, not the 100 meters, because 100 meters is actually this whole part, but this small Nyana part is actually the height of cell phone tower A. So how do we find this small portion? Here's what I suggest. The method that I'm going to use is I am first going to find this part so that we can try to use sine rule to find this small portion and take 100 and minus that small portion to get this large portion, which is cell phone tower A. Now here's what I mean. Let me explain, or let me try to explain. Let's try to name this as A, and this part to here, let's call it B. So we know that here we have 90 degrees and here we have 30 degrees. So we can use sine rule to get A, because we have 90 degrees that is opposite this 100, and we have 30 degrees that is opposite this A. So we can try to use sine rule and say A divided by sine 30 degrees is the same as 100 divided by sine 90 degrees. This is going to, we cross multiply, so I'm going to take this to multiply the 100. So A will then be equal to 100 multiplied by sine 30 divided by sine 90 degrees. So sine 30 is actually 1/2. Sine 90 is 1. So it's actually 100 multiplied by half divided by 1 divided by 1. These are not negatives. So 100 multiplied by half divided by 1, which is 50. So in other words, A is 50. So we can come and say, okay, we know that A is 50. Now, we are only left with finding B. To find B, it's also simple because we have 30 that is opposite B. Let me erase this so that it becomes cleaner. We have this 30 being opposite B, and we have this 90 degrees being opposite the A that we just found, right? So it means we can again use sine rule to find B. So to find B, we're going to say B over sine 30 is equal to A over sine 90. This implies that B is actually A, which is 50, multiplied by sine 30, because I'm cross multiplying, I'm taking this to multiply that side, divided by sine 90. And here we're just going to get sine 30 is actually half, and this is 1. So 50 multiplied by half is actually 25, which means B is 25. Now, to find cell phone tower A, we saw that cell phone tower A is equal to this portion of the diagram. It's equal to this portion. So this portion of the diagram. But this whole portion is equal to 100 meters. So to get this small portion, we're going to say 100 minus the value of B. And the value of B is 25, which means the height of cell phone tower A is actually 75, which is D. Now, question 8 says, suppose ABCD is a square with side length x minus 1 centimeters. It means this equals this one, and this one equals this one. It's actually a square, so it means BC is x minus 1, AB x minus 1, AD x minus 1. No need to annotate DC because it's inside the shape. Right, so if the area of the rectangle, so we are also told that ABFE is a rectangle, which means this AB side is actually equal to this, which means it's x minus 1. If the area of the rectangle ABFE is x squared plus x minus 2 centimeters squared, then the length of FC, we are actually looking for this part. The length of FC in centimeters is, right, now let's see how we can actually try to come up with this. So we know that to get the area of a rectangle, I think that's where we should start. The area of a rectangle, equals to length times breadth, right? So our length in this case is BF, and our breadth is EF, right? So we are actually told that the area of BF multiplied by EF should give us x squared plus x minus 2, right? So we are looking for two vectors that multiply each other to give us what's on the right hand side. So what we can try to do is actually try to factorize this and see if we cannot find two vectors that we can assign to these by inspection, right? So what we can do is try to do this and say, what are the factors of 2 that when we multiply should give us -2, and that when we add or subtract should give us +1, right? So in this case, we can try to end -1, because 2 multiplied by -1 gives us -2, and 2 plus minus 1 gives us +1. So in other words, we can have x plus 2, x minus 1 in this case. So if you look carefully, it makes sense that x plus 2, x minus 1 should be the two vectors, because we already know that EF should be equal to x minus 1 because we showed it in the diagram. EF is actually equal to x minus 1, which means by inspection, BF should be equal to x plus 2. So we can come and annotate this and say BF, the whole of BF, is actually x plus 2. So BC is x minus 1, BF is x plus 2, right? So to get FC, we're going to say FC plus BC are actually equal to BF, because it's the whole thing, right? So FC is what we're looking for, so we're just going to let it be. In other words, BF minus BC should be equal to FC in this case, because we're taking the larger part and subtracting the smaller part so that we can get FC. So BF, we just found that BF is x plus 2 minus BC, which we were told that it was x minus 1. So in this case, we can have x plus 2 minus x plus 1. X and x cancel out. 2 plus 1 equal 3. And 3 is our answer, which is B. Right, we've come to the end of our third part. I'll be finishing the final 2 questions in the next video. Be sure to like and subscribe, and remember to keep education fashionable. I will see you in the next video.